Welcome to this session on extraction attacks. So today we'll explore a critical topic that affects security of AI models, how attackers can steal or replicate valuable models by extensively querying them. Throughout this presentation, we'll dive into the techniques behind these attacks, their motivations, real-world examples, and most importantly, the strategies we can use to mitigate them. Understanding extraction attacks is essential for protecting intellectual property and maintaining competitive advantages. Let's get started. Let's start by discussing what extraction attacks are. Essentially, these attacks involve extensive querying to approximate or replicate the model. In simpler terms, an attacker sends numerous queries to a model with the goal of understanding how it's going to work internally. The key concept here is attackers can use outputs from a model to reconstruct its internal logic, potentially gaining access to proprietary algorithms or intellectual property. The objective of these attacks include model theft. This is going to be where an attacker recreates the functionality of the model without ever needing the original data. Intellectual property theft, where they steal proprietary algorithms and embedded knowledge. Another motivation is gaining a competitive advantage by copying advanced models developed by others, or reducing costs by avoiding the high expenses associated with training their own models. So, what are the motivations behind extraction attacks? Why would an attacker even want to do this? So, they're pretty varied. First, there's the intellectual property theft. By reverse engineering these models, attackers can gain access to proprietary algorithms and data that represent valuable assets. Competitive advantage is another strong motivation. Companies are investing significantly into AI development, and attackers can then bypass this investment by stealing their models, gaining the same benefits without the research costs. There's also the desire to reduce costs, as it's much cheaper to steal or replicate a model than to develop it from scratch. Finally, attackers are motivated by a broader goal of diminishing the effectiveness of competitors' innovations. So now let's talk about some of the techniques used in extraction attacks. One of the primary methods is systematic querying. This is going to be where attackers submit numerous well-structured queries to map out the model's decision boundaries. Another common technique is input-output pair collection, where attackers collect large sets of input-output pairs to understand how the model behaves. Functional approximation comes into play here. Attackers use machine learning algorithms to approximate the model's logic based on the data they've collected. Additionally, active learning is employed, where the attacker strategically selects queries that would reveal the most amount of information about the model. When we move into more advanced techniques, attackers are going to employ things such as black box attacks, where they have no internal knowledge of the model, but still manage to extract valuable information through extensive queries. They're going to employ model-based attacks, which surrogate models to mimic the decision-making process of that target model. Gradient-based techniques involve leveraging gradients, if accessible, to better understand the workings of the model internally. Finally, there's transfer learning, where extracted knowledge from one model is used to enhance or develop other models. Sometimes this can happen even in completely different domains. The impact of extraction models can be quite substantial. For example, uh, intellectual property loss can occur when proprietary models are stolen or replicated. Companies could face competitive disadvantages, losing the edge gained through unique model development. There's a significant economic loss with this as well, with stolen models being used by others without compensation, leading to financial damage. Additionally, security vulnerabilities can arise as attackers misuse replicated models for malicious purposes. For some real-world examples, Language models can be reconstructed through extensive querying. Financial algorithms can be duplicated through querying proprietary trading systems, and even healthcare models can be replicated to access sensitive data. So let's dive a little bit deeper into some specific examples of extraction attacks. For example, language models are often a prime target for reconstruction through extensive querying, allowing attackers to steal very sophisticated models designed for natural language processing. In the financial sector, attackers can duplicate proprietary trading algorithms by systematically querying them. Recommendation systems like those used by online retailers or streaming platforms are also very vulnerable. Attackers can replicate the system's behavior by submitting a series of queries here. And in healthcare, predictive models can be reverse engineered, potentially allowing access to sensitive health insights. Okay, so now let's talk about how we can mitigate these extraction attacks. One of the first lines of defense is implementing strict access controls to limit those who can query the model. Additionally, query rate limiting is another effective approach. Now, this would entail controlling the rate and the number of queries allowed. You can detect and prevent extraction attempts this way. Output perturbation adds slight noise to the model's outputs, making it harder for attackers to reverse engineer the model. Monitoring and anomaly detection can help continuously tracking querying patterns and identify abnormal activities. Adversarial testing is also critical, where we regularly test our models against known extraction techniques. Finally, differential privacy can help by adding noise to the data itself, protecting the information against leaks. To wrap up, extraction attacks they pose a significant risk by allowing attackers to replicate or steal our valuable models. These attacks can lead to intellectual property theft, economic losses, and security vulnerabilities. Advanced techniques like black box and gradient-based attacks make these threats particularly concerning. However, mitigation strategies like query rate limiting, adversarial testing, and differential privacy can help protect against these attacks. It's essential to implement these protections to safeguard our models and maintain the integrity of our AI system.